Good morning. Good morning to all. Myself, B.T.M Nayak, Department of Electrical Engineering, G.I.T, Ghangapatna. I want to share something about the topic electrical engineering material. Electrical engineering material is a fourth theory for the third semester diploma electrical branch students. As a electrical diploma students, you have the idea about the electrical engineering material. The electrical engineering material holds prime importance for electrical engineers in designing, installation, and maintenance of electrical equipments. With the advent of latest metallurgical process, the materials used in the design process brings safer and hazard-free electrical installations. Hence, basic knowledge on electrical engineering material is essential for a electrical diploma engineers. The objectives of this topic is to clarify the students on insulating, conducting, and magnetic materials, to important knowledge on the physics, electrical, and mechanical properties of the material, to impact knowledge on practical uses of various of materials in the different areas. The course contains six topics. First topic is the conducting materials. Second topic, semiconducting materials. Third one is the insulating materials. Fourth one is the dielectric materials. Fifth chapter covers in this subject is magnetic materials. Sixth one is the materials of special purposes. Engineering materials. The materials used for manufacturing the engineering products are called engineering materials. That means the material which is used for the manufacturing of engineering products or engineering equipments, that material is known as engineering material. These engineering materials are the backbone of all engineering products. The design, manufacturing, commercialization, and performance of any engineering product basically depends on the material being used for the product. Semiconducting materials are the base of all electronics devices. Similarly, the existing of electrical engineering machines and equipment completely depends upon conducting, insulating, and magnetic materials. This is a structure of materials or structure of the engineering materials. The one is structure, next is characterized, next is processing, next properties, তারপরে performance. This is the step of the engineering materials. Then next go for the classification of engineering materials. These engineering materials can be classified based on the branch of engineering as below. The mechanical engineering materials, second one is electrical engineering materials, third one is civil engineering materials, fourth one is electronic engineering materials. Means the according to the branch of the engineering, the engineering materials also classified. Means the mechanical engineers use the material known as mechanical engineering material like iron, steel, all the metals. The electrical engineering engineers they use the material is known as electrical engineering material like the conductors, semiconductors, insulators, magnetic materials, etc. Similarly, civil engineers use the material like cement, iron, stone, sand. These are called the civil engineering materials. And the materials which is basically used for electronics components, that is called as electronics engineering material. Let the example is semiconducting material. Electrical engineering materials. First, we go for the electrical engineering material. Electrical engineering material is a successful electrical engineer. It is must be required for a successful electrical engineer. We should have a deep knowledge of electrical engineering materials. Electrical engineering material, since a society with the electrical engineering material associated with the study of composition, structure, characterization, processing, properties, applications, and performance of electrical engineering materials. Now, electrical engineering materials is most important for a electrical engineers. The electrical engineers must know about the structure of the electrical engineering material, composition of the electrical engineering material, what are the characteristics obeyed by the electrical engineering material, what is the process, what are the processes to perform electrical engineering materials, the properties of electrical engineering materials, and where it is application, where it is applicable for engineering materials, and the performance electrical engineering materials should be thoroughly known by electrical engineers. The existing and success of any electrical machine or equipment depends upon the availability of suitable of electrical engineering materials. Means the electrical machine, if you want to construct an electrical machine or electrical equipments, then availability of electrical engineering materials is required for the electrical engineering material for the electrical engineers to construct electrical equipments, electrical machines. The basically these are called as conductors, insulators, and magnetic materials. Before designing any electrical machine, we should have good knowledge of the properties and application of electrical engineering material. I mean, before using the engineering materials for the design of electrical machines or design of electrical tools, electrical equipments, we thoroughly know about the properties and performance and application of that engineering materials. The performance of any electrical equipment is completely governed by the quality of material used for that equipment. Means the tools or the machine or the equipments which basically depends upon the quality of the material which is used for the construction. Therefore, to design a good and successful electrical equipment, we should also have the knowledge of factors governing the quality of electrical engineering materials. The quality of electrical engineering materials is vital for an electrical engineer. The properties and application. Depending upon the properties and application of electrical engineering materials, the categories as conductors, semiconductors, insulators, and magnetic materials. The conductors, like the examples of the conducting materials like silver, copper, gold, aluminum. Semiconducting materials, which are used for electronic components, the examples are germanium, silicon, like this. Insulators in plastics, rubbers, mica, these are the insulating paper, these are the insulators, some example of insulators. The magnetic materials like iron, silicon, steel, alnico, dimagnetic material, ferromagnetic material, nickel, these are the magnetic materials. First, before going to be a conducting material, we should know about the resistance and conductance of the material. But depending upon the resistance and the conductance of a conducting material, we say, we use the conducting material in their applications for the construction of machines, for the construction of electrical equipments like this. Then first we want to know about the resistance and conductance of conducting material or engineering material. What is the resistance? The resistance of a given conductor depends on the material it is made and on its dimension. The resistance of a conducting material depends upon its material for which it is made and the dimension of the material. For a given material, the resistance is inversely proportional to the cross-sectional area. Means the cross-sectional area of the material is inversely proportional to its resistance. Now, what is resistance? Resistance is nothing but is the property of the material which oppose the flow of current through it. That means Resistance is a property of a conducting material which opposes the flow of current through that material. That resistance is inversely proportional with the cross-sectional of area. That means the cross-sectional area of the material increase, the resistance decrease, and vice versa. For example, a thick copper wire has low resistance and otherwise identical thin copper wires use, the thick copper wires having low resistance. If low resistance, then more current will flow through the thick copper wire. For this reason, the wire used for the AC refrigerator grinder like this, the wire is thick wire, and the wire which is used for the lighting purpose is called as fine wire. Also, for a given material, the resistance is proportional to the length. That means another factor is there. The resistance of the material also depends upon the length of the material. That means directly proportional with the length of the material. Means as the length of the wire, length of the material increase, the resistance of that material increase. For example, a long copper wire has a higher resistance than otherwise identical short copper wire. The resistance denoted by R, conductance is denoted by G. Conductance is just a reciprocal of resistance. If the resistance reciprocal of resistance means 1 by R is called as conductance denoted by G. The conductance of a conductor uniform cross section, therefore we can compute as R is equal to rho L by A. The formula for resistance R is rho L by A. Just a reciprocal of resistance is called a conductance sigma A by L. Means 1 by rho is called as sigma. Rho is called as specific resistance or the resistivity. The reciprocal of specific resistance or the reciprocal of specific resistivity is called as conductivity denoted by sigma. The resistance unit is ohm. The conductivity unit is reciprocal of resistance. This is 1 by ohm. That's called the mho or called as Siemens. This is the unit of conductance. The conductor which has more resistivity, that means low conductivity, or the conductor which have low resistivity, that means that material has more conductivity, means it can carry more current. A good conductor. Then we go for the resistivity. Resistivity denoted by rho, in the previous slide. The resistivity of electrical resistance of a conductor of unit cross-sectional area or unit length means for a unit length of wire having unit cross-sectional area, the resistance is nothing but the resistivity. That means resistivity of a material is equal to the resistance if the conductor has unit area of cross-section and unit length. A characteristic properties of each material resistivity is useful in comparing various materials on the basis of their ability to conduct electric currents. High resistivity designates poor conductors. And high resistivity, if resistivity is high, 1 by rho, 1 by resistivity is called as conductivity, automatically conductivity is poor. A low resistivity is a clear indication of a material which rapidly allow electric current. Moreover, the common representation of resistivity is by the Greek letter rho. That letter is rho. The SI unit of resistivity is called ohm meter. See the diagram. Let this is a conductor. Rho is a resistivity, length is L, area of cross section is A, then the resistance is equal to rho L by A. For the resistivity for different conducting materials are given in your screen. Copper has 1.5 into 10 to the power minus 8 ohm meter. Similarly, aluminum has 2.7 into 10 to the power minus 8 ohm meter. Graphite has the resistivity 8.0 into 10 to the power minus 6 ohm meter. Silicon is given. Quartz is also given 5.0 into 10 to the 16 ohm meter. Then another topic is factors affecting resistivity. What are the factors affect the resistivity. The resistivity property of the material is also affected by the various of factors. What are that factors? Now, first factor is temperature. Next is alloying. Next is mechanical stressing, age, hardening, cold working like this. Means if temperature vary of a material, then the resistivity of the material also vary. Some materials temperature increase, resistivity increase. Some material temperature increase, resistivity decrease like this. Means by changing the temperature, the resistivity of the material changes. That means the resistivity depend upon the temperature or the resistivity of the material affected by the temperature changing. Similarly, alloying. If you make the alloy for different materials, then automatically its resistivity is also different. When the copper with the aluminum, if you, aluminum resistivity is one, copper resistivity is another. If both are going to be form a alloy, then the resistivity of that alloy is going to be changed. That means by the process of alloying, also the resistivity of the alloying material changes. Mechanical stressing means by the force of mechanical or by the mechanical stress, the dimension of the material changes. As the dimension of material changes, automatically its resistivity also changes, its resistance changes. Similarly, age hardness, man, due to the long period of use, the resistivity of the material also affected. Cold working means the if the material used in summer, if the material used in winter, if the material used in a cold area, if the material used in high temperature area, then also depending upon the working temperature, cold working temperature or hot working temperature, the resistivity of the material also perform more. I mean like a conductor, like copper conductor, the resistivity at the time of running of a machine is one value. If the machine runs for a long time, the temperature increases of the winding, then the rest bit of the copper value also going to be affected or varies. This is called as the factors affecting the resistivity of the conducting material. Let the resistivity of G1 resistivity is equal to 1 by conductivity, that means reciprocal of conductivity. Then rho is equal to 1 by sigma. Sigma is the conductivity symbol used for the conductivity. Rho is the symbol used for the resistivity. Resistance R is directly proportional to the length increase, resistance increase. Resistance also inversely proportional with the cross-sectional area of the conductor, means thick cross-sectional area of the conductor, low resistance, fine cross-sectional area of conductor having higher resistance. That means R directly proportional to L by A, then R equal to rho L by A, where rho is the proportionality constant known as resistivity. If we find the formula rho, then again it implies that rho is equal to R A by L, means resistance into cross-sectional area divided by length. Take an example or problematic example for finding resistivity. Take a question, let find out the resistivity of a material wire of 2 meter length. A material in wire or metal wire is given whose length is 2 meter and his area of cross section or the diameter is given. Diameter of that wire is given 0.6 mm and its resistance happens to be 50 ohm. The resistance is given of that wire is 50 ohm. Then please find out the resistivity. Then please go for the given data according to the numerical solutions method. Resistance R is given 50 ohm. Length L is given 2 meter. Diameter is given 0.6 mm. Then please convert into 0.6 mm to the meter. Therefore, the radius of the wire 0.6 mm, radius means half, 0.3 mm. Convert into meter, then 3 into 10 to the power minus 4 meter. Then go for area of cross section. Area of cross section is pi r square. Area of cross section pi r square. Pi value is 3.141 into r value is 3 into 10 to the minus 4 square. Then total calculation area is equal to 2.826 into 10 to the minus 9 meter square. Then putting the formula rho is equal to R A by L, R 50, into area is calculated 2.826 into 10 to the minus 9 divided by length is 2 meter 2, then total resistivity is calculated 7.065 into 10 to the minus 8 ohm meter. Ohm meter is the unit of resistivity. In this way, by using this formula, we can calculate resistivity for the simple problems. Next one is the classification of electrical conducting materials. Classification of electrical conducting materials. Electrical conducting material are basic requirement for electrical engineering products. The electrical conducting material can be classified as based on resistivity or conductivity. One is low resistivity or high conductivity conducting material. Second one is a high resistivity or low conductivity conducting material. Means low resistivity material, high resistivity material. Low resistivity material means it has the high conductivity. High resistivity material means it has the low resistivity because resistivity conductivity are inversely proportional to each other. Here, electric conducting material has two types, one is low resistivity or high conductivity material, high resistivity or low conductivity conducting material. First go for low resistivity or high conductivity conducting material. Materials having low resistivity or high conductivity are very useful in electrical engineering products. These materials used as conductors for all kind of windings requires in electrical machines. All kind of windings required in electrical machines, the wire used as a conductor has belongs to low resistivity, high conductivity class C classification of conducting materials. In electrical machines, electrical apparatus, any electrical devices where winding is required, in that case, low resistivity, high conductivity winding materials are used. These materials are also called as conductor in transmission and distribution of electrical energy. The transmission line, the tower, the overhead transmission line, or distribution purpose, electric supply distributed village to village, customer to customer, load to load from power substation to the grid like this. The distribution wire and the transmission wire, in that case also low resistivity, high conductivity materials are used. The what are the materials? Small examples are silver, copper, gold, aluminum. Like this, the four examples. All so many materials are there whose belongs to low resistivity, high conductivity. But four examples are given here. One is silica, silver, copper, gold, aluminum. Next, for high resistivity, low conductivity conducting material. The materials having high resistivity or low conductivity conducting are very useful for electrical engineering products. These materials are used to manufacture the filaments of incandescent lamp, bulb filament. Bulb filament, the material used that is called as high resistivity, low conductivity material. Heating elements like heater, water heater or electric heater or space heater or iron coil, electric iron coil. These are the coils where high resistivity, low conductivity materials are used. The materials like tungsten, carbon, nichrome, nichrome B, nichrome C like manganese, tungsten, carbon, nichrome, manganese. These are the some examples of high resistivity, low conductivity material. Based on the area of application, according to the application area, the conductor materials also classified as materials for heating elements. Those materials used for heating elements, some materials used for lamp filaments, materials used for transmission line, material used for bimetals, means both the metals and alloy materials are used. Electrical contact materials, contact MCB or cutout like the contact materials, blocking, the electrical carbon materials, electric materials for brushes used in electric machine. Electric is carbon brush. The brushes used in electric machines and materials used for fuse. These are diagrams see here. According to the application of according to the application, the electrical conducting materials are classified like this: bimetals, electrical contact materials, electrical for heating elements, electrical carbon materials, materials used for fuse elements, materials used for conductors for the coils, materials for lamp filaments, material for brushes in electrical machines, material used for transmission lines. Next, application of low resistivity materials. Low resistivity, one application of low resistivity material that is called copper. Similarly, second, another is aluminum. Similarly, third is steel. Aluminum, steel, copper, these are the materials used for the is called as low resistivity, high conductivity materials. Then if you go for what is first is called as copper. Copper, it is most widely used metal because shock its high conductivity. Due to shock and high conductivity, it is mostly used. Silver has the lowest resistivity, but due to its high cost, it is not used as the copper is used. The hardness of copper is about 4% less conducting than the allen copper. Hadron copper, allen copper. Hadron copper is about 4% less conducting power than the annealed copper. Annealed copper is used at the place where flexibility is required, like wiring of buildings, winding wires, electrical machines, transformers, like there. The windings of electrical machines and transformers, copper is preferred to aluminum. Copper is preferred to aluminum. This is because aluminum wire have a tensile strength much lower than that of the copper. This results in tendency in the breaking of the aluminum wire under tension as well as developing the resistivity of the aluminum is higher as compared to the copper. Therefore, aluminum wire has to be thicker cross-sectional as comparison to copper wire in case of the I square R loss. According to the concept of I square R loss, aluminum wire having thicker than the copper wire for a constant carrying of current. Similarly, please go for the another aluminum. Its electrical conductivity is next to copper. Copper for a next to copper, the conductivity is called as aluminum. Aluminum occurs in on the Earth's surface. It is available in the various forms such as oxides, sulfate, silicate, phosphate. This form is available on the Earth. Aluminum is a white metal with very light of weight, which is its chief asset. Pure aluminum is softer than the copper, so can be rolled into thin sheets or foils. Due to low mechanical strength, it cannot be drawn into very thin wire. The resistivity is about 1.65 times greater than copper. Keeping in view the resistivity, mechanical strength, and density of the same resistance and length of wire, an aluminum conductor should have a cross-sectional area 1.6 times than that of the copper conductor. The weight of the aluminum is equal to 0.48 times the weight of the copper. Similarly, next steel. Steel is not very often used as a conducting material because of its low electrical conductivity in spite of that aluminum and copper. When the alternating current flows in steel wire, its resistivity increases and the power losses are much higher when the direct current also flows. That means in steel wire is rarely used because of its high resistivity, low conductivity, Now, when alternating current is flowing through the steel wire, then its resistivity increased. That means the power loss is going to be more in case of steel wire. For this reason, it is less used as comparison to copper and aluminum. Next, electrical standard conductors. Electrical standard conductors which is used in transmission line. See here the diagram. The standard conductors are very much popular in electrical power system of transmission and distribution line. A standard conductor is consist of several thin wires. A standard conductor is consist of several thin wires. A small cross-sectional area called standard are shown in figure. See, this is the figure. Means one small standard size of the conductors wound to each other to form a transmission line conductor. That conductor is called a standard conductor. The center of the conductor is the steel standard conductor to make it strong from one pole to another pole, one tower to another tower. But over that steel standard, the aluminum standard conductors are placed which carry the current from one point to another point. This type of wire is called a standard conductor, which is used for transmission distribution purpose. Here, one standard conductor is ACSR. ACSR means aluminum conductor steel reinforced. Center is the steel, the other conductors are the aluminum conductors. Aluminum conductor steel reinforced. It's a bimetallic conductor. The thinner layer are composed by the steel wire and the external layers are composed by hard-drawn aluminum. Next, another standard conductors are AAC, all aluminum conductors. This kind of conductors is composed by one or more layer of pure hard-drawn aluminum. At the center, the standard conductors, we are using steel conductor which provides the high tensile strength to the conductor. The center of a standard conductor is the steel which provides high mechanical strength, high tensile strength so that the conductor cannot be break, cannot be, it can be used for long periods for the transmission and distribution purpose. In the outer layer of standard conductor, we use aluminum conductors, which provides the conductivity to standard conductor. Basic reason of using standard conductor is to make the conductor flexible. If we use a single solid conductor, it doesn't have sufficient flexibility and it is difficult to coil a solid conductor. Hence, it becomes difficult to transport a single solid conductor of long length over the distance. To eliminate this drawback, conductor is formed by using several thin wires of small cross section. These thin wires are called standards. By making the conductor standard, it will become flexible, which makes standard conductor suitable to be coiled easily to transmit from one place to another place for a long distance. There are some factors to be noted about the standard conductors. What are the factors related with the standard conductor? The standard conductor is having sufficient flexibility, which makes standard conductor suitable to be coiled easily to transport it over a long distance. For a standard conductor of some small cross-sectional area, the flexibility of the conductor increases with increasing the number of standards in the conductor. The standard conductor is formed by twisting the standard together in layers. The standards of each layer are laid in helical fashion over the preceding layer. This process is called as standarding. Generally, in successive layer, the standarding is done in opposite direction to preceding layers. This means if the standards of one layer are twisted in clockwise direction, the standard of the next layer will be twisted in anti-clockwise direction and show that X number of layers in the conductor. In generally, the total number of standards in any conductor is given by the formula n equal to 3x square minus 3x plus 1. N equal to 3x square minus 3x plus 1, where n is the total number of standards in standard conductors. Generally, the diameter of the conductor can be calculated by using the formula d equal to 2x minus 1 into small d, where small d is the diameter of each standard. See, this is the diagram of standard. In first one, only one conductor is used. In second one, seven number of standard conductors are used. The third type is called 19 number of standard conductors are used. Fourth type, 37. Then fifth, 61. Depending upon the transmitting voltage, depending upon transmitting power, the 3D, 5D, 7D, or 9D type of standard conductors are used. Thank you to all. Today, this much we will teach to each other. Okay, thank you very much.